Last section, we started talking about precipitation reactions. We saw that precipitation reactions involve the mixing of two ionic compounds, and a solid is going to form. Now in this section, we're going to start doing math with our precipitation reactions to determine how much of each reactant we must mix to get a certain amount of product, or how much product will form if a certain amount of our reactants are mixed. Okay? So example 9 says we need to calculate the mass of solid NaCl that must be added to 1.50 liters of a 0.100 molar AgNO3 solution to precipitate all of the Ag plus ions in the form of AgCl. Now, anytime I'm doing stoichiometry, the very first thing I need to do is write a chemical reaction. Okay? So, I've got NaCl, and I'm told it's solid, is reacting with AgNO3, which is aqueous, to form AgCl, which is solid. Now they don't tell me what my other product is, but I know that this is a double replacement reaction. Ag's partnering up with Cl, so Na's partnering up with NO3. Na's a +1, NO3 is a -1, so everything balances. That will be aqueous. I check to make sure that my reaction is balanced. In this case it is. Only once I have a balanced reaction can I start with the math. Okay? So I'm trying to figure out how much NaCl I need in grams. I'm told that I have 1.50 liters and that the concentration is 0.100 molar AgNO3. Now, whenever I'm doing stoichiometry of precipitation reactions, step 1, I'm always going to take my liters of my reactant and multiply it by molarity to change it to moles. So it looks like this. 1.5 liters of AgNO3 times 0.100 molar, that's moles, of AgNO3 for every 1 liter. Moles per liter is molarity. Okay? So step 1, I want to get rid of liters, change it to moles. Step 2, I don't want moles of AgNO3 anymore. I want to find out about NaCl. Whenever I change from moles of one element or compound to another, I use my equation. That's why I had to write this. It's a 1 mole of AgNO3 for every 1 mole of NaCl. Okay? Last step, now I need to get rid of moles of NaCl. That goes on the bottom. My question asks me about grams. Well, I know that 1 mole is always equal to the grams from the periodic table. If I look at the periodic table, Na weighs 23, Cl weighs 35.5. So the whole thing is going to weigh 58.5. If I plug this into my calculator, 1.5 times 0.1 times 1 divided by 1 times 58.5, I get 8.775. Well, I've got 1, 2, 3 sig figs here, 1, 2, 3 sig figs here, so I can only keep 1, 2, 3 sig figs here. So that's going to round to 8.78 grams of NaCl. Okay? Now, when we're doing stoichiometry problems, we're always going to do the same steps. Okay? I need to have my balanced chemical reaction. Now, this says net ionic. I usually just do the complete formula equation. It's up to you. okay? But you need to know what reaction is occurring, and you need to have a balanced reaction. You're going to change your liters into moles. If there's more than one reactant that they give you information about, you need to determine which one is limiting. And then we're going to change moles to grams or moles to liter or whatever they tell us to do, okay? So here's an example where we're going to have to figure out which one is limiting. They tell me when aqueous solutions of Na2SO4 and PbNO3 are mixed, so here are my two reactants, PbSO4 precipitates. There's my solid. Calculate the mass of PbSO4, so this one in grams, formed when 1.25 liters of 0.05 molar PbNO3 and 2 liters of 0.025 molar Na2SO4 are mixed. So first, I need my chemical reaction. Na2SO4 is aqueous. It's reacting with PbNO3, which is also aqueous. I'm making PbSO4, which is my solid. Now it doesn't need it, but just for completion, double replacement, I partnered up Pb with SO4, so Na is going to go with NO3. Na is a +1, NO3 is a -1. I had 2 NAs and 2 NO3s, so that goes in front. So I've got my balanced chemical equation. Now I'm going to have to do two calculations. One for lead 2 nitrate, one for sodium sulfate. I need to figure out which is my limiting reactant because that's going to limit the mass of PbSO4 that precipitates. So I'm going to start them the same way. I've got 1.25 liters of Pb lead 2 nitrate. So step 1, I change liters to moles by multiplying by molarity. So liters goes on the bottom, moles goes on the top. I'm told I have 0.0500 moles of lead 2 nitrate for every 1 liter. Step 1, change liters to moles. Step 2, I'm going to change moles of PbNO3, so that has to go away, into moles of PbSO4, because that's what it asks about. When I change from moles of one element or compound to moles of another element or compound, I have to look at my balanced reaction. In this case, I have 1 mole of Pb for 1 mole of Pb. Last step, it asks me about grams. So I need to make moles go away. I'm changing it to grams. I know that 1 mole of any compound or element is equal to the number from periodic table. So I look at my periodic table. Pb is 207.2. Sulfur is 32. Oxygen is 16 times 4. Now if I add all of those things together, I get that it's 303 grams. Okay? 0.2. 3.2 grams. So if I plug all of this into my periodic table, I'm going to get 1.25 times 0.05, 1 over 1 times 303 equals 18.9 grams PbSO4. Now this isn't necessarily how much I make. I need to do the same thing for Na2SO4, and I need to figure out which one is limiting. Remember, whichever one is limiting will be the smaller one. Whatever my smaller mass is, that's the maximum amount I can make. So take a second and try to figure out how much PbSO4 I can make from 2 liters of 0.025 molar Na2SO4. So your second problem should have started with 2 liters of Na2SO4. I'm going to have to write small because I wrote that too big. So I've got 0.0250 moles of Na2SO4 per 1 liter of Na2SO4. Okay. Step 2, I need to get rid of moles of Na2SO4. I want moles of PbSO4. Running into room. I'm just going to make myself a little box, and then we'll just come down here for our third step. So I know from the equation that it's a 1-to-1 molar reaction. In step 3, I'm going to change moles of PbSO4 to grams of PbSO4. Now I know that 1 mole is always equal to the number from the periodic table. I don't need to add this all up again because I've already done this. It's 303.2. Okay, so 2 times 0.0250 times 303.2, I should get 15.2 grams of PbSO4. Now, with my lead nitrate, I was able to make 18.9 grams. With my Na2SO4, I'm only able to make 15.2. Because 15.2 is smaller, I know Na2SO4 is my limiting reactant, so the maximum amount I can make is 15.2 grams. Okay?